live. Usually I like to sit here and ponder, what's going on in the world. So this time has been no different, apparently. All right. So here we are, Halloween in the US and some other places I know have started celebrating it. And we thought, or at least I thought, and some other people seem to agree, that it would be fun to talk about Gen AI gone wrong, under the guise of sort of like nightmarish, like what can happen. We got three amazing speakers we're going to have at this event. You can see I have worn a bit of a costume. While I am actually Rachel Romeliotis, a director of open source strategy from Intel, today I am also Louise from Bob's Burgers, obviously. So, with the agenda, like I said, we're going to start off. I'll pull up here in a second a few slides about OPEA just to give people an idea on that. And then we'll just get into the fun. And I hope if you have any stories to share, throw them into the chat, tell us about them. And also, if you have any images to share of you in a costume, I would enjoy that as well. That would make me laugh. Okay, let me start by getting my screen going. Of course, it's not going to be easy. Nope, I don't want that. Not too bad. Okay. Nope, that's not what I want, of course. Darn it. Hold, please. There we go. Can somebody tell me if they can see the screen? Yes. Okay. Let me go back to it then. Okay. So didn't want to make this all about OPEA. Just want to make this about having fun and building out a community of people that are interested around OPEA, around Gen AI. So just a little bit of a snapshot. So for the agenda, like I said, I'll give a little bit of an update. We're going to have Bill Gay from DeepSet talk about the fallback mechanism, haunting errors in RAG. And then Terry Damiba from Quadrant, Gen AI Fright Night. That's a great movie if you haven't seen it. And then Jim St. Clair's going to join us later with Tales from the AI Crypt Keeper. It's like they all got it. I'm really excited about that. And then we'll talk a little bit about awards and results of the hackathon that we had in October. So I just thought this was super fun to talk about. We've been up and running as an official Linux Foundation project, I believe, since like April 16th might be the official day. So about 6 months. And I wanted to throw some numbers out there, and you're part of that community, and I thank you for it. And hopefully, in another 6 months' time, we'll double and triple that. So we've got a bunch of GitHub followers. I remember when it said like 2, and now we have 567, which is super amazing. Lots of those stars that you want to see on, this was just one particular repo, the different end-to-end examples of Gen AI workflows that we have. We started, I know this, with 14 to 16 partners in April. That's what we launched with. And we now have 47, which has been a journey and is amazing and great. OPEA.dev has actually had 20,000 visitors. And all of the different fun events we've had over these last 6 months, we've had about 600 people register. So it's been fun. And these people look like they're having fun, except for that one guy. So I just wanted to throw that up there. So this is currently all of the partners that we have. The latest I added just today is Turin Tech. I don't know if they're here, but shout out to them. But as you can see, all different parts of the ecosystem, big companies, small companies, companies from around the world, and more, they're activating and contributing, and we're working with them to figure out how to do more and more. So there's exciting times ahead. So I wanted to give you a little bit of insight into what's coming up with OPEA. Lots more. I think there's about 16 end-to-end examples that you can take a look at right now, but there's more coming. I know that the chat Q&A with Knowledge Graph is either is already in there or is right around the corner. We'll be turning our gaze to AI agents soon. As far as components, refined service APIs, knowledge graphs, and an open search vector DB. Different functionality in the form of Helm charts. That's what I keep hearing from everybody, more Helm charts. So people are excited about that. A new benchmark from the community, long context, and then new model compatibility with the ones you see here, and more hardware support from Intel, and really hoping AMD is working towards being able to support lots of the OPEA stuff. So all very exciting. You're also going to start to see solutions and appliances underway under the logo powered by Open Platform for Enterprise AI. So I just wanted to throw that up there to get people excited. And I'm going to save those for the end. And so that's basically it. So hold on, let me find you all. I'm going to put this down here and unshare. Figure out how to do that. How do I unshare? Stop screen. There we go. Okay. All right. So with enough of me here at the beginning, I'll be back in between sessions. But I'd love to welcome Bilge from DeepSet AI. They have amazing technology, Haystack amongst it. And they're going to be working on incorporating that into so that OPEA can work with Haystack. And she is here to talk to us about those haunting errors. Thank you so much for making time today, and I'll throw it over to you.
Thank you, Rachel, for the nice introduction. Yeah, it's great to be a part of the OPEA community and be amongst OPEA partners. So I'm quite excited to be here and share the presentation with you and talk a bit about the errors in RAGs and the fallback mechanisms.
Awesome.
All right. So yeah, the slides are hello, everybody. Welcome. So in this presentation, we'll talk about the fallback mechanisms, and with those fallback mechanisms, how you can hunt errors in RAG. So let's start. First, a little bit about me. My name is Bilge. I work as a developer relations engineer at DeepSet, and DeepSet is the company behind the open source LLM framework Haystack. I am based in Istanbul, Turkey. I was born and raised there, and I still live there. I am on social media, so if you're on Twitter or if you like to connect on LinkedIn, here are my nicknames and the links. You can go out and check, and we can connect there. And here's today's agenda. First, I'll give you some brief information about RAG and LLMs. I know everybody heard about them before, but I'll just give the basics again. Then we'll talk about the challenges that you can have in RAG systems. Then we'll see a fallback mechanism, how to fix that challenge. And I'll show you some examples of how to actually implement that fallback mechanism. And hopefully in the end, we'll have some time for the questions. So if you have any questions during the presentation, feel free to write it in the comments and I will be giving you some answers. Right. So RAG, and in long form, retrieval augmented generation. So in order to understand RAG, first we need to understand LLMs. So LLMs, large language models, are quite famous, and I am sure that most of you have seen this UI before. It's an application that runs an LLM behind, And I use this application almost daily for to fix some errors in my messages, maybe make an email to more clear. But sometimes I use it to get some information for things happening around the world. So I use this question, what is Taylor Swift's Tortured Poets Department album about, just recently? And as an answer, I get that there seems to be some confusion, as Taylor Swift does not have an album titled Tortured Poets Department, etc. So it doesn't know what I'm talking about, although this album was released in April. But this is something that we expect, because we know that although these large language models are trained with huge data sets, there is some certain point that happened, they don't know what's happened after that certain point because they don't have the data. And clearly, this model running behind didn't know about the things happened at least after April this year. But doesn't mean that I cannot use LLMs to learn information about the latest things happening in the world. And the answer is, I can use actually, but in order to use LLMs with updated data without fine-tuning them, is called actually retrieval augmented generation. And I like to call it a fancy way of prompting, because instead of just sending a question to the LLM, I create a fancy prompt with instructions and relevant context, and then I send this very long, not very long maybe, but this relatively long prompt to my LLM to get an answer. And the LLM, now that it has some context, even though the information wasn't in its training data, can answer my question this time. So this application also started to incorporate that technique to the UI. So when I ask the same question, this time it knows that it's not in its training data, or it assumes that the training data might not be up to date. So it goes through web, gets some relevant information, and generates an answer based on that context. That's good. It means that RAG kind of solves most of the problems if I like to interact with large language models with updated data. But there are also some challenges in RAG, and let me go through one of them that you can see almost daily. Imagine you have a RAG system. So you have a vector database where you store your documents, you're doing retrieval, you have a large language model, there's a mechanism to generate this RAG prompt that sends it to the LLM. So this RAG is working, definitely. And then there's a question coming. You can see that I'm a Taylor Swift fan, by the way. So there's a question, and the question comes like, when is Taylor Swift's next concert? And your RAG system gives you an answer like this. The document do not provide any information about Taylor Swift's upcoming concert. This is scary. This is scary, especially if you're using RAG for your customers or for your users. Imagine getting this answer in a chatbot. This is not the best user experience. But don't get me wrong, if we were in the early days of generative AI, where the LLMs were starting to become popular, I would hope that it would give me this answer instead of hallucinating or just spitting out some random date or just one date that it found in the content. But this time, now that we have more advanced solutions and more advanced systems, I believe we can do better than this, just showing that we don't have the answer. And this is where fallback mechanisms come into play. And as an example to a fallback mechanism, what you can do is to incorporate a routing system in your RAG. So this time, if we can get a date, or my large language model returns a date, I can directly show that date to my users, and this means that this query is resolved. But if I get an answer like this, where the information is not found in my context, I can do different stuff based on my use case. What I can do is I can do web search. So go and try to see other alternative resources. Maybe I can try to check a different database. I can raise a Slack alert. I can send a send an alert or open a ticket to my customer support team, and tell them like, okay, there was a user, they asked this question, but our RAG system failed. So just go ahead and check what's wrong there. Or you can do some like advanced RAG techniques such as like query expansion, metadata filtering, query decomposition. Based on your use case, maybe you can use a different retrieval technique, especially for those type of queries, instead of showing this response directly to your user. But okay, in theory, they all look really good, but in practice, how do we actually implement this? And here I will be showing you a bit about Haystack, the open source LLM framework. But before that, there is this one trick that we need to do in our RAG system, and I'll show you this. This is really easy. So on the left-hand side, you'll see a very basic RAG prompt. I just give a very short instruction, then I put my context, then I put my query, and send this basic prompt to my large language model. But we saw that this sometimes doesn't work. But this case, for the fallback mechanism, I'll just add a one sentence to my prompt saying that if the answer is not contained within the documents, reply with no answer. This is just one sentence, but this is really powerful. And then I will just put my context and query. So you will see in the following slides how this instruction is going to be useful. But before that, let me introduce you Haystack. Haystack is an open source Python framework for building production-ready LLM applications, and it provides you the tools that you need to build your application. It has tools to help you build a prototype, then to evaluate it, deploy it, and monitor it when it's on production. Haystack comes with two building blocks, components and pipelines. Components are the smaller units. They can do one thing, but they are really powerful. And by connecting components to each other, you form pipelines. But pipelines in Haystack are directed graphs. This means that you can have loops in your pipelines, or you can have branches, or you can merge those branches. So you can go quite flexible here. And if you we give you a lot of tools to build your application, but if you think that there's no integration for that tool in Haystack, or maybe you are using a very specific tool that is special for your organization, and you can just create your own custom Haystack component, and without any problem, you can incorporate that component to your pipeline, and your pipeline becomes complete. And let's see a very basic RAG pipeline implemented with Haystack. Then I will show you how to implement this fallback mechanism on top of this. So we start with an embedder, right? There's this query. I create an embedding for that query by using an embedding model provider out there, and you can choose your embedding model, whether they are from a Hugging Face, so open source ones, or the ones that you host yourself, or maybe you want to use a model coming from a model provider behind an API. Then I am using an embedding retriever to get relevant information to the query embedding. And to store your embeddings, to store your documents, you can again choose your favorite database out there, and Haystack has an integration for that. Then there is this prompt builder component that renders the prompt for you in Haystack. But prompts in Haystack are using Jinja syntax. So it means that you can have for loops in this prompt, or if statements. So this gives you more flexibility as you define your prompt, even when you want to build something more complex than a RAG pipeline. So imagine you have one part of the prompt once one of the conditions is met. So this is really powerful and dynamic, especially if you are building a very complex pipeline. And then as the last step of your pipeline, you have a generator component that gets the rendered prompt and sends it to an LLM out there to get a response. And then you get an answer to your query, basically, with this RAG. But since we want to incorporate a fallback mechanism to this RAG, there's something further that we need to do. And additional thing is this conditional router component that you can that we have in Haystack. And what this conditional router does is you define some conditions in this router, and by checking those conditions and the input coming from the RAG pipeline, it directs your query to the relevant branch. So in this example, we have 2 branches, but you can go quite flexible here. You can have 5 branches or 5 different conditions. So it helps you a lot with the conditions. And what I have in my mind is I want to detect whether the response coming from the LLM is a valid answer. Then there's no problem. It will go to the branch here. But if the answer is not a valid one, so it's actually a no answer, then I can go to web, or I can go and check my Notion. I can go my Google Drive files, or I can send something to the Slack channel. So I am quite flexible here, but I'll just show you briefly how to use the conditional router. So here's how you define your condition. First, remember the instruction that we have given in the prompt. We were telling the LLM to return no answer keyword if the answer is not found in the context. And here in this conditional router, I just check the reply coming from the LLM. And if there is the no answer keyword in there, I send this query to my go to fallback branch. But if I don't see this no answer keyword, it means that it's a valid answer, then everything is great. This is my answer. I will return that to my user. So it gives me the capability to assess the response coming from the LLM and direct it to the corresponding branch. All right, then after detecting the answer, I can implement a web search here. So what I do for this one is I have a component called web search. This component basically gets the prompt, goes to web, just like you have seen in the UI, finds more relevant information, and gives that into the prompt builder, just like in the RAG example. Prompt builder renders a RAG prompt, sends it to the generator, and this time, hopefully, this pipeline generates the correct answer. And this is one way to implement this fallback mechanism. But another thing that you can do is to implement a Slack action trigger component yourself that is connected to your Slack. Maybe you like to also log the user ID, the documents used to generate that response, which LLM model used, or user query, anything you want, you can log to Slack and have it there to report to your team. So this was it. Thank you for listening. And if you'd like to see the complete example of this, you can check out this QR code. It will take you to one of the tutorials that we have that has the full code for the fallback mechanism to web. And you can try Haystack by running pip install haystack-ai. It's completely open source. And there will be some more coming soon with OPEA, so stay tuned. And if you like to connect on social media, of course, you can find me on Twitter and LinkedIn. Thank you. And I think it's time for questions. I hope we have some time for questions.
Hello again. Let me look. We've got 72 things happening.
All right.
So if anybody, it seems that we're having trouble with the Zoom, the sort of the core invite channel. So I keep putting in the link to go to LinkedIn. So if you're having trouble, go to LinkedIn if you're listening. Okay, let's see if there's anything. I'm just looking through here. So if anybody does have any questions, definitely let us know. Let's see, comments. I don't see any yet. Who's got a comment? Who's got a scary comment to give to us? No, I don't think. I don't think we have any.
All right.
But I completely appreciate all of your work on this. Was great. I think the theming was an added bonus for all of us.
Yeah, I don't have the costume, but I have the theme.
Anything? I don't see
now
anything.
I'm getting crosstalk here. Hold on, please. Sorry.
Okay, so we say go to YouTube. Okay.
Okay, people are just figuring out the Zoom thing. Apologies. Sorry, please continue. Okay. Now my screen is not running. Okay, sorry. Hold please. Well, anyways, let me go find my way back. There I am. Okay. Well, thank you again. And
Thank you.
you can go deal with the streaming mess. But I appreciate you doing this today and hope to work again with you in the future.
Yeah, thank you for having me.
Of course. Who do we have next? I believe it's Terry. Terry, you better have some good images for us. So Terry comes to us from DevRel at Quadrant, and he is going to be talking to us about scary images and GenAI. And I feel like we talked about this actually when Terry suggested this to me, that like we both were like instantly like, yeah, they're horrifying. So I was like, please do this.
Yeah.
He said he would. And here he is. And I'm going to go ahead and give you the floor.
Awesome. Let me know if you guys can see my screen. Okay. I'm assuming I'm good to go. Yep. Cool. So I want to talk to you today about Quadrant. We're a vector database. If you're not familiar with vector databases, think of it as AI management for your data management for your AI application. So if you're building something like recommendation, search, or generation, like we're going to talk about today, Quadrant's probably going to be the vector database of choice. You can go to our website and take a look at the clients that we have. We serve a wide variety of clients, but we do focus on large data. So you'll see that a lot of our customers are companies that have a lot of data. They need to get their recommendations, they need to get their anomaly detection, things like this really fast. And that's where Quadrant excels. But of course, we offer 1 GB free to anyone when you're getting started. So we also do cater to those people in the garage. So now that you have a bit of an idea about what Quadrant is, I want to talk to you about image generation. So recently, there was a new model, which now we know what the model is, but before it was like an anonymous model. And it topped the image generation leaderboard. And Black Forest Labs has been at the top since they put out Flux 1, and then they released Flux 1.1. So this was a bit of a shakeup in the image generation. And what I want to do to start is actually show you what Red Panda Recraft looks like, right? So here, their sample image is a portrait of a cute red panda using a laptop. Poster has title Red Panda Redcraft V3 against a red background. And as you can see, the picture is pretty faithful. I would say that's a cute panda, and they got the text perfectly correct. So what I want to do now is change this to something that is going to be a little more Quadrant themed and a little more OPEA Fright Night themed. So instead of this, we're going to say OPEA Fright Night against a, let's go space background, because Quadrant really likes space. So, and as you can see, you can even adjust your string size as well as the style if you wanted to do some different things. But for here, we're just going to do that normally. And what you'll see is that it's going to faithfully reproduce the image that I asked for in my prompt, right? OPA Fright Night, that looks like a little cute astronaut, right, on a laptop. So that's just kind of your intro into what image generation is. If you're not familiar with it, or if you've used it in the past and you haven't used it recently, I would highly suggest that you come and check out some of these new models, right? We have this emoji model. You can make yourself into an anime character. We've got kind of this panel situation. So, hey, if you want to look like a model, we can do that for you. So there's tons of different models that are available now. And if you haven't messed around with AI image gen, I definitely recommend that you take a look at what's available because landscape is rapidly shifting. Now, unfortunately, I've shown you some good stuff, some cute pictures. I'm going to go ahead and show you some pictures that you're probably not going to love. So these pictures, and I think I might have them too large, so we can just take a look at them here. And I can even maybe make this smaller. These pictures are what one might consider kind of like creepy AI art, right? So I don't know if you're getting the heebie-jeebies. I'm getting the heebie-jeebies looking at pictures like this. It's kind of this idea of there's off and you can't tell exactly what it is. Unfortunately, these images aren't great quality, but it's like these are all AI generated images. And I mean, if you look at them too long, luckily I've been messing around with it for a while, so I've become desensitized. But I remember the first time I saw an image like this, just getting goosebumps all over my arm because this stuff's creepy, man. This stuff's really, really creepy. I'm gonna keep going just to creep you out a little bit more. You can see even just coffee, if it's not correctly created, it just gives you that queasy feeling. What the heck is going on, right? Okay, enough of that. Ugh, that made me feel weird. So what I did was I took that data set, which I just showed you, and that data set is actually something called a tryptophobia data set, where we have 500 images that are creepy, and then we have 500 images that are basically normal images, right? And what I did was I put those images in quadrant. So you can see here, we've got 1,000 points. And you can see here, I've got all of these images in here, right? And I just called them scary hands and incremented them. But basically, you'll see some of these images are normal AI generated images, and then some of them are creepy, right? And the idea is you could use quadrant to actually be an evaluator for your image generation system, because what we can do is not only visualize our points. So right here, you can see all of your points in latent space or vector space, if you will, right? So you can see, what's related to that like picture there? Okay, we're staying in the vegetable range, we're in the fruit range. It makes sense that these were grouped together, right? And the beauty of this is I'm not using any metadata here, right? Later on, I'm going to show you a collection where I do have metadata in, but Quadrant has just figured out magically that these images are similar without me tagging it as it's a brown image or it's a fruit. It just looked at the image, ran it through a clip model through Fast Embed, and then all of a sudden, if we look at these points, like it knows, hey, these are all cartoons. I should put them together, right? And then we also have another algorithm that you can use, which is called, I believe, UMAP, which is just a different way of putting them together. So you can kind of cluster in these different ways and see, how did you decide to cluster for UMAP versus TSNE, which I'm not going to get into now, but if you're into stats, go ahead and Google that. So we have that visualize feature, right? But the cool part of Quadrant is we also have this graph feature. So if I'm just going to keep the limit here, and then we're going to have to define a sample, which I will make 1,000 points because that's how many points we have. Oops. And then I also need to make sure that my tree parameter is true. And when I hit run, what's going to happen is basically we are going to get a graph of all of our images. So boom, I hit run, and I'm actually going to make this a little smaller so we can see the graph a little better. And what we have here is I have limited the nodes to 5 maximum, but I could make it 10. I could make it 2. Depending on your use case, maybe you want to change the amount of limits that you have. And of course, you can change the sample. You can also, we have other parameters in here. So if you wanted to filter on certain things, if you wanted to use a specific vector, you can also do that. So the idea here is now we have this beautiful, I'm going to bring the limit back to 5 just as a default to traverse this graph. Now we have this beautiful graph, right, with all these images in it. Some of them are real, some of them are fake. So we can kind of start to see what is the relationship between the real images and what are the fake images. When you hover over the picture, it's going to show you what that image is. And as we keep going, it's like, okay, these two images are really similar, right? It makes a lot of sense that they're together. And if we keep going down this line, what we'll see is, okay, like it's a little less similar, but I understand the track that it's going on. Still look like these kind of oblong objects. And then if I keep going up here, it's a little more far away. Okay, I see why it's related. And the idea is you can traverse this all the way to the middle and you can make the point in the middle whatever you want it to be, right? So of course, if I go to another side of my chart, I'm gonna see completely different images. Now I'm looking at, it looks like Roman coins. If I go up here, all of a sudden I'm looking at a map of a country it would look like, or maybe a satellite shot. Okay, guys robbing stuff. So when you're generating your image, the idea is you could check to see the similarity score of a similar image, and based off of that, give a go or no go on whether you want to serve that image to the user, right? So if you've ever used something like ChatGPT, sometimes it's going to give you multiple answers and it says, hey, which one do you like best? You can basically create a system like that, and that's what image generation models do, where when you send that query out, it might actually create 4 or 5 pictures. And then it's going to run a similarity score to a perfect picture, if you will, right? A golden data set, which if you're not familiar with, let's say you had a model that was trained on the SAT, we know what the answers are. So we can actually test to see the accuracy of the SAT. For pictures, it's a little more ephemeral and kind of taste-based, because what is a good picture of a dog? Well, that depends on your opinion, right? But there are certain things that we know should be in a good picture of a dog. Probably should have 2 eyes, 2 ears, things like that, right? So you can build your similarity search like that. Now, I want to actually show you guys 2 different collections to sort of show you the power of Quadrant. And let me just refresh that. Sorry. So we've got the H&M clothing data set, right? And this is where the metadata comes in. So earlier I mentioned that with the other collection that I'm using, and I can actually pull up that collection side by side just so that we can see the difference. So in the H&M clothing, 1 second here, let me just rearrange my screen. In the H&M clothing data set, you see we have all of this metadata, right? Where I fed it the article ID, what's the product name, what's the product type name, what's the product group name, what's the graphical appearance, and on and on and on, right? So I basically, all the way down to a very detailed description of the product. Whereas here, for it to find the similarity based off of anything other than literally the embedding of the image. Here, I'm taking a more thorough approach, something that you might see more in production, like if you are running a company that's selling clothes and you wanted to recommend clothes to users. So now I'm going to go back to this graph and we're going to do the exact same thing. So, oops, sorry, sample 1000. I think this has more, but just so we can actually traverse this graph reasonably, I'm going to keep it at 1000 and then make sure that my tree is true and make sure I have my commas. I'm good to go. So we see here that we have this, what is this? It's a jacket, I guess. That looks kind of very high fashion. I'm not that high fashion. But the idea here is I'm just going to start at a random point. Oop, I did not mean to click that. So let me run it again, just so we start fresh. So here we have this. It's a pair of shorts. And you can see this is going to be a pair of shorts, but probably a little different, right? A little lighter blue. Here we have another pair of shorts, I'm going to guess. Let's see. Oh, this, yep. So that's another pair of shorts, but it's white. And I mean, you can kind of get the idea, right? If you wanted to make recommendations and someone bought this product, you can come in and you can actually click on that point and be like, what are the closest neighbors to that point? Oh, these are baby clothes. Well, they bought the baby navy striped tee. Well, they might be interested in the baby overalls that are striped as well, right? So that kind of logic applied to recommendations is something that we've seen a lot of people have success with in e-commerce, right? Because now all of a sudden you have this beautiful way of looking to see, like, for example, you could put your top selling product as the center of this chart. And then all of a sudden you can go and you can say, hey, how similar are certain items to the top selling product? What can I recommend based off the top selling product? And then on the other token, you can go out to the edge and be like, why are these products so dissimilar? And is there something that we need to do so that they will sell better, right? So this is an example of how you can use the quadrant graph in an e-commerce setting because you want to do recommendations or just get a better understanding of your data, right? And then the other thing that I want to show you is actually on quadrant.tech. So this is going to be on our cloud interface. And if you're not familiar with Quadrant, basically, there's 3 different ways you can use Quadrant. You can use it locally in Python or in a Colab notebook. You can use it with Docker, or you can use it on the cloud. If you use it locally or on Docker, then it's going to be using your resources, of course. And if you use it on the cloud, then we are going to provide that cluster for you. And as I mentioned earlier, everyone gets a gigabyte cluster for free for life, no credit card or anything required, because we want people to basically be able to prototype in Quadrant and see, hey, this works for me, it doesn't work for me, right? We don't think you should have to invest a bunch of money just to find out if Quadrant's a good fit for you. So as this is loading, I'm just gonna go back to StreamYard, see if there's a chat. It looks like nothing is going on. Oh, terrifying. Yeah. I'm sorry, I didn't mean to scare you. So this should load. I believe since I'm streaming, it's probably doing a number on my network. But when it loads, basically what I want to show you is the Midjourney data set, which is going to have a bunch of artificial intelligence created images. And in those images, what happens is basically we're going to group those images based off of the specific style of the image. And it looks like this is lagging for me, so I have to apologize. Maybe I can't show you that right now. So I'm just going to go back to my local host. And show you the last thing that I had planned for you, which was I went ahead and I actually I created some images of scary hands. And the idea was I wanted some scary hands that looked like they were well done. And I also wanted some scary hands that maybe were malformed. This is actually getting harder and harder to do with the image models that we currently have because they've become so good at not giving you weird images. Even when I put in hands, you can see an image like this. It's like, it's creepy, and it didn't get it exactly right because we can see here there's an extra finger, so this hand would have 6 fingers, but it's pretty close, right? It's doing a pretty good job of capturing some scary hands. And then there's some other examples where it's maybe not doing as good a job, right? Let me try to find a bad. Yeah, so this is probably like, okay, I kind of see where you're going, and this is definitely creepy, but I don't think the prompt scary hand should end in like whatever this is trying to do for me, right? I actually don't love looking at this. So the idea that the other idea that you could use Quadrant for is if you're creating these images, you can actually come in here and you can look at your graph, and we're going to make the sample 20, and we're going to make sure that our tree is true. And I'll change the limit to 2 just because we have so small. So the idea here is it's literally now separated my tree because of how different these images are, right? So we can clearly tell, hey, there's something weird going on because this doesn't even have any neighbors to this. And it makes sense because if I actually, ooh, this one's really creepy. Oh, geez. It makes sense because if we look at the images, we see that these are all kind of photorealistic hands, right? These ones less so, but still photorealistic more so than, for example, this hand, where it's like, this is clearly drawn, right? So the idea is if you want to create art for, let's say you're creating a website that's going to generate photos for people for headshots. Well, you can come in here, put in a bunch of good headshots so that when someone generates a headshot that isn't good, it's going to fall outside of a certain similarity, and you can have a flag that says, hey, we probably want to check that out. So that is basically my presentation. I also have a Twitter that I'm trying to grow. So I would love for all of you to go ahead and follow me on Twitter at Terry P. Damiba, and go ahead and also give me feedback on the presentation if you don't mind, right? I tweeted about it, so feel free to hop in under there and tell me what you liked about the presentation, what you didn't like, what you want to see next time, how you felt about my costume, anything like that. So thank you so much for letting me present, and this was awesome.
It was, the images were more horrific than I expected.
Got you. I mean, you asked for it, Rachel.
I did. You did a really good job. A really good job.
Thank you. I try.
There are a couple of questions, if you don't mind. I think
I never mind.
Okay. One is, does Quadrant Fast Embed have algorithms to embed combined image and text?
Yes, we do.
Okay, great. And can you use the UI to modify metadata and descriptions to get embeddings closer to each other?
Ooh, I'm glad someone asked that. Why don't we just hop into the web UI real quick, Rachel?
Hop right back in. Yeah.
Do I have time? Okay. Sorry, I don't mean to.
You do have time.
Okay, awesome. So as far as I understand, the question was, can I edit my points once I've upserted them, right? Because I don't want to have to re-upsert my points. I've already got them in there, right? So let's find this H&M clothing. And there's that little beautiful pencil that we love to see, where I can come in here and make this menswear, or I can make it white. I can make it blue. And of course, let's actually look at this 0.0 and see where it's going to move if I actually change the payload. So for sample, we're just going to do like 10 so that it's very clear that it's moving. And then I'll make that tree true. So we run it. Okay. We got ID 354. So I'm going to change ID 354 and try to see what happens. And as you can see, once again, all of these items are pretty similar, right? Right now, if we look at 354, it's looking at it and it's saying, hey, it's like a t-shirt. Then it's going to this woman's clothing, or I should say jacket, because I only have 10 points, right? So keep in mind, since I only have a sample of 10, it's the similarity score is going to be a lot more sensitive. Then it went to kind of this mini t-shirt, then it was like this dress, and then from sheer to underwear. Okay, so the idea here is if we find 0.350, oh, I should have looked at the ID. No, okay, so I'll just edit 0.0. I'm sorry. And then instead of this being black, we'll make it white. And then instead of ladies wear, or instead of women's jackets, I'll say men's jacket. And then I'll just keep it like this and see what happens. Okay, so you're going to have a little diff that shows up to let you know, hey, you are changing your payload. Are you sure you want to do this, right? Because it's not something we want people to do accidentally. But you can just go ahead and confirm that. And then I'm just going to visualize, or sorry, I went to the wrong place. I'm going to graph. What am I missing here? Oh, semicolon. That might have been too many points. It's going to be hard to find it there. Oh, no, it's ID1 shows up automatically. So maybe I just edit ID1. My apologies. That was a bit silly. Instead of 0.0, I want ID1. Invalid. Oh. There we go. And then instead of gray, we'll make this black. And then instead of green, we'll do red. And then instead of jacket, we'll do shirt. And then I'll do indoor. I don't even know if indoor is a category. But, oh, sorry, wrong tab. The idea is if we change the sample to 10, that was much more reasonable. Now, all of a sudden, the things that it's related to don't really make sense, right? Because it's like, I changed what was in the payload. So the idea is if you want to, you can come in here and yeah, you can always custom edit your payload because we know sometimes you just have a bug or you just want to change one point to see what the impact is going to be and you don't want to re-upsert everything. So yeah.
That's awesome. Yeah, that totally went awry there with the women's shirt and then pajama pants and everything. So
Exactly. Yeah.
cool. Well, thank you so much. It was really fun. And like I
Thank
said,
you.
I look away at points.
Yeah.
But I appreciate it. And I hope you have a great rest of your day. So thank you so much.
Thank you.
All right. We are on to the crypt keeper himself, Jim St. Clair. No, I'm kidding. His thing was called oh, maybe I was wrong. It is him. Tales from the AI Crypt Keeper, the nightmares of AI security.
Hello, thank you, Rachel, and hello, kiddies, as we probe
Amazing.
AI security.
Well, I like that you're in the mood, and I'm just going to hand it right over to you. Give us what you've seen.
The crypt keeper is figuring out how to properly load his slides because the crypt door won't open.
It happens.
Bear with the crypt keeper a minute.
No problem. Yeah, present, I think, if you have it there, and then from there, there's some choices.
Yeah, you have to have the slides uploaded into StreamYard first.
Oh, I didn't have to do that.
Oh, yeah, that was the first thing to ask me. Let's see here. So present, slides, processing. The door slowly sliding open. And while we're doing this, I will include the reference in the LinkedIn chat to the OWASP top 10 that we'll be talking about today.
Always good.
Yep.
Not a top 10 you want to be on necessarily?
Not the top 10. It is the top 10 of horrors.
Yes.
Aha! The door is swinging open.
Oh.
Yes.
All right. I'll leave you to it.
Thank you. Hello, everyone, and welcome to your AI security horror stories. Beware of generative AI threats told to you by the Crypt Keeper. We're entering the haunted realm of AI. Welcome to a journey through the dark side. Today, we'll uncover threats lurking in generative AI and large language models like ghosts in the shadows. This is intended to be an overview of the Open Web Application Security Project Top 10 Security Risks for AI and LLMs, of which many of you may be familiar with OWASP, the Open Web Application Security Project, of which I think the first time I saw a list was 1998. So they've been at these top 10 lists and finding ways to improve web application security for some time. And with the advent of AI and LLMs and the technologies we've talked about, they've added to that one now. Why does security matter in generative AI? Just like haunted houses come with their own risks, generative AI brings unique challenges, and these risks can haunt developers and users alike if they're left unchecked. So let's go through some of these, shall we? The ghost in generative AI. Hidden vulnerabilities like unseen ghosts haunt generative AI models. A single oversight can unleash a specter of malicious activity. And in this, the very first of the top 10 list, prompt injection. AI attackers can manipulate your large language models through crafted inputs, causing it to execute on the attacker's intentions. There's been quite a bit written about the challenges of various models with prompt injection, and I believe during the excellent presentation on RAGs, we talked a bit about guardrails and using RAGs for some of these techniques for adjusting the prompts. Some models have specific prompting vulnerabilities that are to be discovered, and there's ways to explore this in the top 10 where they give some mitigating strategies for ways to ensure that you're not unleashing any ghosts in your prompting structure and architecture. Next, we have the vampires of AI resource hijacking. Attackers can drain your resources like your blood, turning your AI into an energy-sapping vampire, siphoning compute and slowing productivity. So the insecure output handling, LLM vulnerability number 2, is an example of a vulnerability that arises when downstream components blindly accept large language model output without proper scrutiny. Many of you, of course, are familiar with cross-site scripting, CSRF, SSRF, other techniques that the OWASP Top 10 has featured for a long time, and as many of you know, are still zombie code, causing problems with cross-site scripting in many cases, and now LLMs and AI are only adding to that complication of security and an area to try and protect as part of your architecture and structure for implementation. Then there's goblins in data poisoning attacks. These are really sabotaging your model's data. Things like training data poisoning, which is LLM vulnerability number 3, risk number 3. It refers to manipulating the data and fine-tuning process to introduce vulnerabilities and backdoors or biases that could compromise the model's security. Or over-reliance on LLMs, which is in your data science strategy or implementation strategy, using LLMs too frequently as part of the generative process that may require things like RAGs and guardrails and some of the other techniques we discussed for mitigation strategies, and not including those as part of the decision making for how you're using AI and AI governance. We have model inversion, exposing the ghosts of user data. Model inversion techniques can summon ghosts of sensitive data from generative models and putting privacy at risk. One example that can manifest from this inversion is denial of service, which is the LLM risk number 4. It occurs when an attacker interacts with a large language model in a way that consumes exponentially high amounts of resources. This can result in decline the quality of service and the quality of the performance, the ability for the LLM to perform calculations, and incurring high resource costs, where all of a sudden you're gobbling up cloud space and your manager turns white with terror when he takes a look at his utilization bill. Zombie models, or unauthorized clones, which are unauthorized copies of models that, like zombies, can take on a life of their own. Excessive agency has been identified as a vulnerability, number 08, in LLM systems, in which vulnerabilities caused overfunctionality, excessive permissions, or too much autonomy, like a zombie wandering free. LLM model theft, where unauthorized access and exfiltration of LLM models, which, in addition to things like economic loss and reputation data, may be unauthorized access to sensitive data, especially if you're using local models that you've created with data of your enterprise that is considered proprietary, sensitive, have privacy information, so on. Adversarial attacks, which are like spiders in the web. LLM applications can inadvertently disclose sensitive information or proprietary algorithms. This is LLM risk number 8. It can result in intellectual property theft, privacy breaches, regulatory compliance issues, even legal snafus, and the loss of information to competitors or result in similar ransomware type attacks. Insecure plugins, which are being used to manage your LLM. This is risk number 7. These may be prone to malicious requests, leading to harmful consequences like data exfiltration, remote code execution, and privilege escalation due to insufficient access controls and improper input validation. And you'll notice through all of these constant themes around access controls, limiting privileged access, safeguarding the data and having controls over the data, and monitoring the LLM's operations as all being critical, just like with other network security requirements. Or you could have a ghost town of forgotten models, abandoned security updates, and a failure of your configuration management process with your LLMs. This is embodied in LLM risk number 5, supply chain vulnerabilities. It can compromise training data sets, deployment platforms, create biased results. You could have LLM interactions and engagements you weren't even necessarily aware of being maliciously directed by an attacker. They can become ghost towns with vulnerabilities haunting due to the lack of security updates. And these are security updates that are promulgated now through CSVs and CVSs, excuse me, and other updates for known vulnerabilities as part of frameworks of LLMs or the LLM architecture and implementation itself. Lastly, one of the big issues that always comes up that is a ghost hiding over all of it are the witch's brew of ethical concerns. Even when you're using your LLM safely and securely, the way that the LLM is used in generating biased outputs or misinformation can be a brew of deadly elements, potentially causing widespread harm. Then, of course, there's the curse of the black box, which as an open source foundation, we know is always a problem. Opaque models, proprietary systems, generating results with no understanding of what's going in and going out and how they could lead to risk and vulnerabilities you're not even aware of unless the black box maintainer somehow provides it for you. Or you may not be able to understand the software security supply chain and the chain of custody and the development of that black box model to know how it's actually running and who is receiving inputs and outputs from it. So protecting against all of AI's dark magic requires security best practices. Just like silver bullets protect against werewolves, certain best practices help protect generative AI from threats. To mitigate these risks, LLM applications should employ data sanitization, appropriate usage policies, as we mentioned, privileged access management, restricting types of data that are returned by the LLM. There should be a limit to plug-in functionality, or else that functionality should be well documented, be testable and auditable. Permissions and autonomy for what's absolutely necessary. Again, limited privilege and access, track user authorization through user audits, and require human approval for certain actions, implementing authorization in downstream systems. So in conclusion, there is a light in the darkness as we guide you out of this crypt. The AI world may seem haunted, but with proper security measures, we can make it a safer place for everyone. Thank you, and I hope you have a happy Halloween.
That was amazing. Thank you for the extra that you put into that.
Gotta have a little
session.
fun.
Thank you. I appreciate it a lot. And that's great. There's so many aspects that are still relatively new that I feel like so many of us have to be aware of. So it's great that each of the topics that we had really touched upon different areas.
Yeah, and in my conversations with other working groups in healthcare for AI and others, I try and maintain a back to basics discussion. Obviously, like in government generative AI, we talk about NIST controls because those are all required, and those carry over for healthcare too. And they really still envision things like we mentioned access control, system integrity, system communications. Those are principles that don't change just because now we're magically using AI to do things.
Right? Exactly. Awesome. Yeah, that makes a lot of sense. I call that the eat your vegetables part of things. So, all right. Well, thank you so much.
Certainly.
We are going to move on and end things with a recap of our hackathon. So let me go ahead and get my slides back up. 1 second. Let's see here. This. Okay. Okay. So let's go through this. So this was, I put this together sort of midway. So for our first event on September 30th, we had 105 people registered. 58 people actually showed up, which I don't know if anyone here is involved in virtual events. That is a amazingly high number. So very excited to have over half the people that said they were going to show up. So that's really great. Issues created for the hackathon. It kind of wavered a bit, but it actually ended up being about 79. A portion of them were docs. We'll talk about that in a minute. What was really cool about this hackathon was that it helped bring people sort of into the community, and especially our Slack channel which is where I'd love for people to have conversations either about OPEA or issues that they're having with Gen AI, really like basically tripled. So that's amazing. So there's a good group of people there. And I don't think I have it here, but our mailing list it got bigger too. So, and if you ever have anything for those of you that are here that you want to add to that announcement, let me know, and I'm happy to do that. So then mid-month, we actually did a check-in. And so we had a person from Zillis come in and talk about the Milvis Vector DB. So that was really cool. We didn't have so many people live, but what was cool about that was, and the number continued to go up in the week or so after, LF AI and Data has a YouTube channel. And so even this one right now is being shown live on YouTube and LinkedIn. And people will be able to watch it in both places, both on LinkedIn and in the YouTube channel. So you can see that people did that, which was really cool and satisfying. And so having these events is great, but you can also, watch at your leisure later. So we had some partners participating, and by participate, I mean either came to the event, amplified our message, went ahead and did some hacking, put in, an issue or two. For this last event, we actually had 168 people registered, which is really cool. We ended up having 3 sessions, all from outside of Intel. And the awards, I'm sorry to say, have to wait, and I'll explain that in a minute. But Spooky Factor's been like out of control. Like people have brought it more than I thought they would, and I'm really really proud. So of those 79 open issues, there are 25 issues assigned. And there are only a couple closed so far, but it looks like some more need to be closed and or are really close. So I need to do just a little bit of work over the next day or so before we can give any awards out. But I did want to thank the hackers that were active. There were 19. If I somehow missed you, please let me know, and I'm happy to add you to this list. And then we had a lot of different issue creators as well, which is an important part of doing things. So the next event is, I put this link in the LinkedIn chat, and we'll make sure to get it out to everybody, is another Demopalooza. So we had one of these in August that was well attended, and we had some cool things there. Prediction Guard spoke. This time we'll do, again, a what's new with OPEA. Hopefully a lot of the stuff that I said is forthcoming will be in place. We also have a demo of getting OPEA up on the IBM cloud, which is really cool. We've had a couple of experiences where we're working through shifting a RAG workflow from OpenAI to OPEA, and that has been really interesting and cost savings, and we definitely want to show you that. And then something that I have been sort of involved with outside of the actual coding has been getting GraphRag examples up and running on OPEA. And so that has been really interesting. And I'm actually going to speak along with a couple other people on it at Neo4j's virtual event called Nodes on November 7th. So it's been really fascinating seeing why you would add a knowledge graph to a RAG workflow, and there are pluses and minuses. It's a lot more expensive, but it's a lot more precise, and for certain workflows you really do need it. So this is just a gateway to get you into opea.dev. It's not a hard URL, so I don't know if you need this QR code, but this is where we're at. And then let me stop sharing. And let's see if we have any questions. Just some funny things. Jim answered. That's good. So that's really it. So if you are in a place that celebrates Halloween, I hope you have some fun. I'll be going out and trick-or-treating with my niece, and you can tell I enjoy this holiday. But I really appreciate all of you stopping by. We definitely want to do more fun events, virtual events, as we move forward. Like I said, we have Demopalooza next month. It's about 3 weeks away, a little bit more. And would love to hear feedback, what you'd like to see, if you have ideas, if you're working in OPEA and you have something to showcase, happy to showcase that alongside you. So thanks again, and good afternoon, good morning, and good evening. Bye.